bullet is fired in a horizontal direction with a muzzle velocity of 300 meters per second. In the absence of air resistance, how far will it have dropped in traveling a distance of 20 meter, 40 meter, 60 meter? And how far will it drop in 1 second? Okay. Now, let's say the gun or the bullet was fired in a horizontal direction, and we fire something in a horizontal direction. It's a bullet. So if it goes in a horizontal direction, we fire it in a horizontal direction. Of course, as the bullet is losing its momentum to be coming down gradually until it finally hits the ground. As such, it's going to trace out a parabolic path like this. There is a motion of a projectile, something like this, as it travels along the path. So now they are telling us that when you travel a distance of 20 meters, how far will it have dropped? The distance of 20 meters here is the horizontal distance since the bullet is fired in the horizontal direction. So as it is coming like this in the horizontal direction, there are two components of motion, the horizontal motion and the vertical motion, because the bullet was fired above the ground, but as it travels along, it begins to lose momentum and the height that it started with will be decreasing gradually until it hits the ground. So this distance given here is the horizontal distance. So and we know that whenever something moves in a parabolic path, the horizontal component of the motion is independent of gravity. As such, G is 0. So if that is the case, however, that horizontal component of the motion is dependent on the velocity of projection. So if I have the distance traveled, the horizontal distance traveled to be 20 meters, using the equation S equal to ut plus half gt squared. And like I said earlier, the horizontal motion is independent of acceleration. So in that case, g is 0. If that is the case, is the 20 meters they are given to us, the horizontal distance. So 20 equal to initial velocity of projection is 300. The 300 t, everything here is 0 since g is 0. 0 times half is 0 times t is 0 and 300 t, not 30 t. So 300 was the initial velocity is 300. Dividing both sides by 300, that implies that t is 20 divided by 300, which is 0.06667. The t is equal to 0.0667 before decimal place in seconds. Then now the question asks us to find how far it will have dropped after traveling this very distance. So what we calculated here is the time taken to travel this distance. The time taken to travel this distance of 20 meters is 0.0667. With this time taken now, we can know the height of the bullet above the ground at that very instance. And we know that since this thing is coming like this in a parabolic path, the vertical component of the motion is independent of this initial velocity of projection. No matter how the bullet is dropping from a height, that has nothing to do with the velocity of projection of 300 meters per second. So initial velocity for dropping something from a height is 0. So u in this case is 0, u is 0. However, the vertical motion is dependent on gravity, so g is 10. And we are looking for s, the distance or the height of the bullet above the ground. But the question says how far will it have dropped? In other words, what is the height of the bullet above the ground? The bullet is dropping as it's losing momentum. So at what height it is in this very instance, this very distance, which we calculated the time taken to reach the distance. So the time is 0.0667 seconds. Using this same equation, in this case, the vertical distance now, which is ut, and the object is dropping, so g is t plus half gt squared. In this case, u is 0, so this first term is 0. So concentrate on this half gt squared. So half gt squared is half times 10 times the t is 0.0667. Now 0.0667 squared is already there in the memory of the calculator. So let me just square it. That is 0.00444. Then this 2 here 1, 2 here 5. We multiply that result by 5 times 5 by 0.0222. So the distance or the height of the bullets above the ground is 0.0222 by 0.222 meters. This is the height it will have dropped after traveling this distance of 20 meters. And let's do that of 40 meters is the same thing. So in that case now, when it has traveled a distance of 40 meters using this same equation, that distance is horizontal distance, which is independent of gravity. So that's equal to ut, because this one is 0 and the s there is 40. 40 equal to the velocity of projection is 300, 300 t, dividing both sides by 300. 40 divided 300. 40 divided 300 is 0.1333. 0.1333 to 4 decimal places in seconds. That is the time taken to travel a distance of 40 meters. So with that time taken, now we can get the height of the bullet above the ground, the height or the distance it must have fallen. Okay, so using the same equation in this case, we're talking about the vertical distance now, which is dependent on gravity. So G is 10, or is independent of initial velocity of projection. So U is 0. U is 0. In that case, S equal to ut plus half ut squared. The whole of this is 0 since U is 0. So working on this, that is half times 10 times the time taken is 0.333 squared. 11333 is already in the calculator, so let's just square it. And that is the result. Then 2 here 1, 2 here 5. Multiply that result by 5 to get the distance. The times 5, 0.088. So the distance above the ground is 0.088. Let me round the last one to the 9 meters. Then finally, the third one, the distance of 60 meters using the first equation, that S equal to ut, since this very distance is independent of gravity. So G is 0. You're repeating it over and over again so you can stick to your memory. There's something moving in parabolic path. There are two components of the motion. The horizontal is independent of gravity. So G is 0. The vertical depends on gravity but independent of initial velocity of projection. So 60 is equal to U there is 300. And because this is horizontal distance, so that depends on the velocity of projection. So 300 times t, then dividing both sides by 300, t is equal to 60 divided by 300, which is 0.2 seconds. And now, using the same equation now, calculating the vertical component of the motion, which correlates with the height the bullet has fallen after traveling this horizontal distance. So now, S equal to vertical distance is independent of velocity of projection. So the first term of this equation is 0, but G is 10. So working on this, there is half times 10 times the time taken there is 0.2. And I forgot to put square there. The formula is half GT squared. Okay, so square this. 2 here 1, 2 here 5. Now 0.2 squared is 0.04. Then multiply by 5, 0.2. So it will have fallen a height of 0.2 meters when it has traveled this very distance of 60 meters. So the question B is how far will it drop in 1 second? In 1 second, in that case, they have given us the time taken after firing the bullet. And recall that dropping from a height does not depend on the velocity of projection equal to ut plus half gt squared. This is 0. Concentrate on this, which is they give us the time, they say 1 second. So half times 10, the gravity, acceleration due to gravity, times the time is 1 second. So 1 square. Here, 1 square is 1, 1 times 1 is 1. So the bullet will have fallen a distance of 5 meters after 1 second.